Hello, Algebra 1 CP students. Hopefully you're having a great day so far. Last time, if you recall, we talked about parallel and perpendicular lines in general. Notice that this was the notes that we had. We defined parallel, it's two lines that have the same slope and never intersect. Perpendicular, two lines that intersect at a right angle and have opposite reciprocal slopes. So we went through a couple examples as to how to find a line that's parallel to another and a line that's perpendicular to another. Now, can you, from this graph, write the equation of a line that is parallel and write the equation of a line that is perpendicular to the given graph? That's your do now challenge for now. Take about 4 minutes, pause the video, see if you can think about it, and come back about 4 minutes from now. All right, hopefully you had your opportunity to pause the video and try it out on your own. Definitely encourage you to do so if you have not. But let's deal with it. Parallel and perpendicular. Let's see what we can do. Well, before I think we even go ahead and start doing that, I think it would be helpful to find the equation of the line in general, just to figure out, well, what the heck equation of this line is it? So, what we need in order to find the equation of the line is the slope as well as the y-intercept, right? We need to fill in these two pieces of information, the slope and the y-intercept. So here, if we look at the graph, let's see if we can identify those. Well, I see that the y-intercept is right here. That's the point where the graph happens to cross the y-axis. That would be at 0, -1 in this particular example is the y-intercept. Meaning that my value for b is -1. So I'd get y equals, at least we have a -1 over here. Now, how about for the slope? Well, to get from one point to another, you can pick any two. We notice that I would have to travel down 1, so that's -1, and over 1, 2, 3 to the right. So your slope, therefore, rise over run. Your slope, again, is rise over run. And you can say that that is down 1 over 3 or -1/3. Correct? So we can say that the equation of our line is y equals -1/3 times x minus 1. That gets rid of the first part. That's just the equation of my line, which is great. Now, how do I find something that's parallel to that? Well, to find the equation of a line that's parallel, I'll do that in green over here, to y equals -1/3 x minus 1. What I can do is I recognize parallel lines have the same slope. So my slope of -1/3 needs to stay the same. -1/3 x. Right? My slope of -1/3 still stays as down 1 over 3, -1/3. But my y-intercept needs to change, but it can change to really whatever we want it to be. Any y-intercept will be parallel. So let's just say, for the sake of, example here, let's say +5, just because, right? And that line, if you notice I'm going to draw it right now, will be parallel to this because it has the same slope. Check out what the graph looks like. I went to 1, 2, 3, 4, 5 right here. If I follow my slope of down 1 over 1, 2, 3, down 1 over 1, 2, 3, same thing. And if I went this way, we could do the slope in reverse. Up 1 over 3, up 1 over 3. Notice if I connect all these points together, like this, trying to do the best I can to draw a nice, pretty picture here. Notice that those lines are parallel to each other. They will never intersect because they have the same slope. All right, hopefully that makes sense. See how they're like traveling in the same direction, and no matter where you are, they're the same distance apart from each other, right? This is what, 6 units above this. This is 6 units above this. This is 6 units above this. 6 units above. They'll never hit each other. All right? So that's how we can find a line that's parallel, same slope. To find a line that's perpendicular, I'll do that in blue over here, perpendicular. Remember that now we need an opposite reciprocal slope. If my original slope was -1/3, the opposite means we're going to switch that negative to a positive, so -1/3 becomes positive. And 1 over 3, the reciprocal, is going to flip-flop to 3 over 1. The denominator jumps up top to the numerator goes down to the denominator. So your opposite reciprocal of negative 1/3 is positive 3 over 1. Hopefully that makes sense to everybody. So that means that the slope of my line has to be y equals 3x, right? The positive 3 has to be the slope. And now, what's the y-intercept? Well, again, we're not given any specific information, so we can make the y-intercept whatever we happen to want it to be. In this case, just for the sake of example, let's do, I don't know, -6. Okay? Y equals, sorry, I should have written it in blue. Y equals 3x minus 6. There we go, we're in blue now. So notice that this line has an opposite reciprocal slope, which is why it's perpendicular. Take a look at what the graph of it will look like. Here's -6. 1, 2, 3, 4, 5, 6. 0, comma -6 is our y-intercept. Again, we just picked that point randomly. Just wanted to show you a nice clear picture. And if I now follow my slope, up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Take a look at what this graph will look like compared to the other ones, right? It's going to intersect, but it's not just going to intersect randomly. It's actually going to intersect perfectly to form that 90-degree angle, right? Do you see that? These all intersect at now right angles. And a lot of times this little square symbol is used to represent a right angle, if you haven't seen that before. This little square symbol means it intersects at a perfect cross, a perfect right angle, right? And so I think an interesting takeaway from this is notice that any lines that are parallel, right? For any lines that are parallel, this perpendicular line is perpendicular to both of them, right? And if we drew another line that was also parallel to this red line and this green line, well, it would also be perpendicular to the blue line. And the kind of same reasoning goes in reverse. If I drew another line, picked a different y-intercept that was perpendicular to the red line and the green line, well, it would be parallel to this, right? It would be like over here somewhere. So perpendicular lines cross at that 90-degree angle, and no matter what you pick the y-intercept to be, they're going to be perpendicular to any of the other parallel lines. Does that point, hopefully that point kind of makes sense? And if two lines are perpendicular to the same line, consider the green line, the red line, both perpendicular to the same line, then therefore they are parallel to each other. All right. You talk a lot more about those visual connections in geometry, but I think it's very important to make, especially since we were talking about graphing lines, of seeing these sort of visuals here. But again, geometry next year for many of you, that will be the primary focus. All right. Great. Hopefully that made sense as to how to do that, and it should have been a nice review too of creating an equation given a graph. Now, that being said, as I sort of hinted at the other day, where are my examples? They're right here. As I hinted at the other day, yes, we did problems that were just create a parallel line. Write the equation of a perpendicular line. Very open-ended. Now, what if I had to create an equation of a parallel and perpendicular line that happened to go through a particular point? In fact, it has to, right? Well, now we don't necessarily have that free choice anymore of just, let's pick any y-intercept we want. We have to figure out what specific y-intercept is going to make this work. So the instructions here say, given the equation of a line, y equals mx plus b, write an equation of a line that's parallel and an equation of a line that's perpendicular to that equation that passes through the given point. So our task is, given this equation, y equals -3x minus 1, we have to write the equation of a line that's parallel to that, and we have to write the equation of a line that's perpendicular to that. All right? Let's start with, and that passes through the given point. Let's start with parallel. Okay? Again, if two lines are parallel, then that means that they have the same slope. So to ensure they have the same slope, that means this -3 has to stay the same. And I would say, well, my parallel line is y equals -3x. But what do I put for my y-intercepts? Well, we can't just now make up whatever we want because I have to ensure that it passes through that point. So for now, let's just put a plus b because I don't really know what that y-intercept is. But now I can use, just like before, literally it's, hold on, I have my examples from before. Ooh, these were the do-nows yesterday. Just like these, where I reach a point like this, where I know my slope but not my y-intercept, I know my slope but not my y-intercept, we're now fusing these two ideas together, parallel and perpendicular, and this stuff, to say, well, I created a line that's now parallel to this, but I need to figure out what b is by using this x and this y. So we can say here that in order to make this happen, in order to make it go through this point, then 1 has to equal, that's y, negative 3 times negative 3, because x is negative 3, plus b. That means that 1 has to equal 9, negative 3 times negative 3, positive 9, plus b. And then subtracting 9 from both sides, we would end up that negative 8 is equal to b. And so since b is equal to negative 8, we would find that the equation of the line parallel to this that passes through this point would be y equals negative 3x minus 8. Okay, that's the equation of the line parallel to this line because they share the same slope, and it passes through that point by using that y-intercept. All right, if you don't believe me, take a look at a graph of it on your own. You'll see that that's exactly the case. All right, that's parallel. Let's deal with perpendicular, and then we'll do the second example the same way. Ready? Perpendicular. Well, again, we have to come up with the slope. If I know that my original slope was negative 3, then my perpendicular slope has to be the opposite reciprocal. Since we're starting with a whole number, if it helps, you could write this over 1 because any whole number is equal to itself divided by 1. And to find the reciprocal, let's just, to find the opposite first, actually, negative will go to a positive. To find the reciprocal, let's just flip-flop the numerator and denominator, and we'd end up with positive 1/3. The opposite reciprocal of negative 3 is positive 1/3. So that's my slope. I don't know what my y-intercept is yet, though. I have to actually use that point in order to find it. But we can do that, right? We've done that in the past couple days. So I can say, well, given this x and this y, it would have to be true that 1 should equal 1/3 times negative 3 plus 1. Well, 1/3 of negative 3 is negative 1. So we'd say, oh, sorry, plus b. My fault. My fault. I said, let me backtrack because I almost misled people. I'd say 1 has to equal 1/3, that's the slope, times x, negative 3, plus b. I mistakenly wrote plus 1 here, but we haven't changed this b yet. We're about to find out what b is, though. I'd say 1 equals negative 1, that's 1/3 of negative 3, plus b. Add 1 to both sides, we would get that 2 is equal to b. So the y-intercept that makes this occur is 2, meaning that the equation of my line has to be y equals 1/3 x plus 2. And there we go. Alrighty? Hopefully that's making a lot of sense. Let's do another example just so you see another one, and then we'll call it a day. All right, so let's do another example. Again, we're looking for a line that's parallel to this and passes through that point, as well as a line that's perpendicular to this and passes through that point. So let's give it a shot. Let's start again with parallel. If the line is parallel, that means it has to have the same slope, correct? So my starting slope here is 1/2. My parallel line has to have a slope of 1/2. But I don't know, again, what y-intercept is going to possibly make this work. I don't know off the top of my head. We have to figure it out by saying, here's an x that's given to us, here's a y that's given to us. Let's insert x in for x and y in for y and figure out, well, what line would be parallel to this and pass through that point. Ready? I'd say 1 equals, because that's y, 1/2 x, x is negative 4, plus b, I don't know what that is yet. Half of negative 4, is -2. Again, you can use a calculator to do that if you really, really need to, but I really encourage you to think about that logically. It's just saying half of -4. That's -2, right? You don't need to. I feel like a lot of students tend to panic when they see fractions and get nervous. There's no reason to get nervous. Just think about it logically. Half of -4 is -2. Or if you really want to do it mechanically, you could write this as -4 over 1. Multiply the numerators, 1 times -4. Multiply the denominators, 2 times 1. You'd get -4 divided by 2, which is -2. However you want to approach it. But again, that shouldn't be a moment of like confusion and people freezing and not sure what to do. All right, just be careful about that. Plus b is still here too, right? We didn't get rid of that. Now let's figure out what b is. We just need to add 2 over to this side of the equation to eliminate the -2. And we'd end up with that 3 is equal to b. And so therefore, I'd be able to say the equation of my line that's parallel is y equals 1/2 times x plus 3. Notice it would be parallel to the original because it has the same slope. And if you check on a graph, you would see it does pass through that point. Last but most certainly not least, let's handle perpendicular. Again, to find something that's perpendicular, you would need an opposite reciprocal slope. So if our starting slope is 1/2, the opposite reciprocal, we're going to switch the positive to a negative, so it's going to be negative. And 1 over 2 is going to flip-flop to be 2 over 1. And -2 over 1 is just -2. Right, getting kind of close to the edge of the paper there. So my perpendicular slope would be -2. The opposite reciprocal of 1/2 is negative, that's the opposite, to the reciprocal. I'd say y equals -2x, but I still don't know what b is. So plus b, I don't know what that y-intercept has to be. But again, we can figure it out by saying here's x, here's y, let's plug in. I'd say 1 has to equal -2 times -4 plus b. -2 times -4 is +8, so we'd say 1 has to equal 8 plus b. Subtract 8 from both sides to get what b is. Gives us that -7 is equal to b. So the line that's perpendicular to this and passes through that point would be specifically y equals -2x minus 7, because that's your y-intercept. And there you go. All right. Notice again how we're sort of fusing those two worlds together. The idea of writing the equation given a point, and we find the slope by basing on whether it's parallel or perpendicular. If it's parallel, the slope's the same. If it's perpendicular, the slope is the opposite reciprocal. But still, regardless of which one it is, we then continue from this point by plugging in x, plugging in y, just like we did before, plugging in x, plugging in y, just like we did before, and we get the equations of our lines in that slope-intercept form, that y equals mx plus b form. Same thing down here. All right. Hopefully that made sense. Just as a little quick recap, we looked at the connections today between graphing, where we saw that if you can look at a graph, get the equation of the line, we can find one that's parallel to it, and we can find one that's perpendicular to it. And we see how they look when you actually place them on the graph. These lines are parallel because they'll never intersect. This line is perpendicular to both, actually, because it intersects at that 90-degree angle. We then saw over here that we can create equations of lines that are parallel and perpendicular, just like we did yesterday. But now, those equations can specifically be forced to pass through this point by using this coordinate for x, this coordinate for y, to figure out what that y-intercept, that b value, should be equal to. All right? Cool. We will practice this more next week, so if it seems a little overwhelming, that's okay. We will definitely do a little bit more practice. We will have another progress assessment coming up on it, though, and a summative assessment soon after, so please, please, please be prepared for that. All right? If you have any questions, feel free to let me know. Other than that, I hope you have a fantastic rest of your day and study hard. And have a great weekend, because it's Friday, the day this video is going up, so enjoy. Take care, everyone.